Hello everybody and welcome back to another video of Liger Science. And in today's video we are going to do some technical drawings for mechanical design. We will continue on doing some sciencey stuff later on too, but for now we'll be focusing on a bit of mechanical engineering, and there will be some math videos coming out in the future. So let's get started. For this video, I'm going to be using a Faber-Castell mechanical pencil here, 0.7, and I'll also be using a Faber-Castell pen, which is also 0.7. This video is not sponsored by Faber-Castell, but it'll be amazing if they did. I'll be using this wooden ruler here with this, along with this set square. So that is all the equipment you need. So let's get started with today's first drawing. Today we're going to draw something called an O bearing. But before we get started on drawing bearings or anything else, let's start with the terminology, or sorry, let's start with the symbols, the syntax of it, of how to draw technical drawings. Right. So first we have here a shaft. Usually a shaft is denoted by a line, usually horizontal line that goes through like that. I hope the pencil shows in the video. I think you can see it. So in a principal sketch, that is the sketch we do before the technical drawing, in the principal sketch we usually use a horizontal line to denote the shaft. In a technical drawing, a final drawing, we use a dotted dashed line, usually a very long, like long dotted dashed line with long dashes. All right, so that is how we do shafts. So shafts are things that spin, right? They're basically rods. Okay, and then for bearings, there are different types of bearing. There are the fixed bearings, there are the floating bearings, and there are the partially fixed bearings. So let's start with the floating bearings. So for floating bearings, we usually use, we usually put bearings on shafts. We usually use two lines like this to denote a floating bearing. And in technical drawings, we do something like this with no shoulders. So if it doesn't have a shoulder, then we know that it is a floating bearing. So if there's no shoulder, we know that this is a floating bearing. It means that it is free to move this way. Sorry, the shaft doesn't move. The shaft rotates like that on its axis. There's axial motion, but the bearing moves like that. It can move like that. It doesn't necessarily move like that, but it can. And then we have the fixed bearings, which are usually drawn like this. So this is a fixed bearing, meaning that the bearing cannot move this way because there's this line here. These line basically means that they can't move like this way. Sorry, not that way. Like they can't move yeah, that way. So bearings are allowed to move this way. Bearings can move that way. Bearings cannot move this way or this way. The floating bearing can move alongside like this. So the floating bearing has some degree degree of freedom restriction. So there's a restriction on the degree of freedom. It cannot move up and down. It cannot move left and right. It cannot rotate like that. It cannot rotate like that. It cannot rotate like that. But it can freely move like that. The fixed bearing is simple. It is fixed, meaning that it can't move like this. It cannot move like this. It cannot move like this either. But they're bearings, so they both can rotate like that, right? So to draw fixed bearings on our final sketches or technical drawings, we usually put them with two shoulders. I think this is a bit too dim for you to see, which is why I will also provide an image. So we're gonna probably have a shoulder here, and a shoulder here, and a shoulder here, and a shoulder here, and also most likely from the housing too, we're gonna have a shoulder here, here, and a shoulder here, and a shoulder here, things like that, right? So we're gonna, it's basically fixed. It can go nowhere. It's got shoulders everywhere. And now finally partially fixed bearings. They are, so we got a shaft here. Partially fixed bearings are bearings that are only fixed to one side. So for example, it can be fixed to this side, or it can be fixed to this side, right? This is the shaft. So like that. So if it is fixed to this side, then there is a contact point here and here, and here and here. If it is fixed to this side, there's a contact point here and here and here and here. So if you draw a technical drawing of that, it will look something like this. So for this one, there is gonna be the bearing. There's gonna be a shoulder here, or anything really. It could be a circle clip, and then another thing here, right? So it will look something like that. You can see here, and yeah, there you go. Same thing on this side. There's going to be a shoulder here, and then another shoulder here, you know, so on. So yeah, I'll provide images on screen later on, but this is just a sketch. For this, it's the same thing mirrored. So here, how you can see there's a contact point here and a contact point here, right? Contact point here and contact point here. So these are the contact points. You kind of see it that way. So we have one contact point, one contact point, one contact point, one contact point. Like that, it is partially fixed. And then this is the mirror image of that. So if you want me to draw that, sure. We have one contact point here, and then one contact point here. This is the shaft. Again, we use a dotted dashed line to denote the shaft. I'm not gonna draw it because this is just a stupid sketch. The one here, you know. So I'll do it in a O-bearing arrangement, and that will help you understand more. Right. So I'll put the images on screen. So those are the bearings, sorry, not the bearing, the symbols that we use, the technical syntax that we use for drawing the principal sketches. For the final technical drawing, I'll show you how to draw the final technical drawing. I do not have the symbols for those, but for the principal sketches, those are it. All right, great. Then let's move on and start drawing our O arrangement bearing. All right, so first we're gonna do our sketch with our pencil first, and then we're gonna do the final sketch with a pen. All right, just this video is not sponsored by Monster, by the way, but if they did sponsor, it'll be great too. Right, I'll be using this wooden ruler to draw our first principal sketch. So our O bearing arrangement is going to consist of a shaft. So let me see how long, just draw any like length you want. I'm gonna draw about this long, right? And we're gonna have first, because it is an O arrangement bearing, the bearings are gonna point in this direction, this direction, this direction, and this direction. I think you can see the O arrangement there. We have 1, 2, bearings like that. Okay, one bearing is pointing this way and like a C shape, and then one bearing is pointing this way and like a reverse C shape. So one like this, one like this, right? So let's try drawing that and see what it looks like. So our first bearing, oops, will look something like this. There you go. This is what our first. Oh wait, I think we messed up. This is an X arrangement bearing. Sorry. So like if you mess up, you can just always erase your mistakes. Don't worry. This is why we use pencils. It's gonna be, yeah, it's gonna point this way. Sorry. Let me redraw the shaft. There you go. So it should actually look like this. There you go. So this is going to be our first bearing, and if you look at the direction that they're pointing, one is pointing in this way and one is pointing in this way, so they're like in a parentheses, open bracket shape. And then we do the same thing on the opposite side, but with a reflection, so they're pointing in opposite directions. So let me show you what that will look like. There you go. And so this is our O bearing arrangement. So as you can see here, we have a bearing with shoulder here, and this downside is the like a reflection of that. So we have a shoulder here and here, shoulder here and here, shoulder here and here. Yeah. So if you trace where the forces are acting upon them, so the forces on this shoulder is acting kind of in this line of action, and then the forces on this shoulder is pointing in this line of action, and then if you trace them, they make this kind of diamond pattern, which we call an O arrangement bearing. Right. Now I'm gonna draw the same thing exactly, but with a pen. So let's get started. Let's first draw our shaft. Oh, this pen really flows really smoothly. And then just copy the thing above, you know. I'm just going to copy what we drew in our pencil sketch, but it is important that you understand why we're drawing it this way, and what we're actually drawing. Kind of messed up a bit on this one, but yeah, there you go. This is our O arrangement pairing. Just do this to make everything kind of symmetric. All right, there you go. The O arrangement. Right, so let's get started with our. So now that we have our principal sketch, let's get started with our technical drawing, the final kind of draft. But first with a pencil, so that we can erase everything first back. But let's first get an idea of what it might look like on the side here. So I'm going to draw what it might look like on the side. um, we're we're gonna have to draw our axial main shaft line for the shaft. So we're gonna have a dotted dashed line like that, and then we're gonna have our shaft running through like so, like that. All right, and then we are going to have our bearings. So we're gonna have one bearing here, one bearing here, you know, the same old bearings. And because it is an O arrangement, there's gonna be a shoulder right here, a shoulder right here, a shoulder right here, a shoulder right here, because we need a line of action to go through like that. And then we're gonna have a shoulder up here, shoulder up here, shoulder up here, shoulder up here. Just connect them. And so our final sketch will look like this. So this is gonna be our housing, and this is gonna be our bearings. So that means that the shaft will look something like this. This is what our shaft is gonna look like. This is our shaft that spins. We're gonna have a shoulder here, and then we're gonna have our bearing going through like that. So, you know, and then we're finally gonna put our housing in. So our housing, we're gonna have shoulder here, and yeah, this is our housing. There we go. So let's draw this. So yeah, these are rubber. So as you can see here, we have a contact point here, contact point here. That means that the first line of action is going this way. Contact point here, contact point here. First line of action is going this way. Contact point this way. Contact point this way. And you can see this makes an O arrangement. Circle. Same like just redrew this here. So we have a contact point here, contact point here, contact point here, contact point here, and then contact point, contact point. So the forces are acting in this line of action that creates a O bearing arrangement. So let's draw it on here to see what it will look like. So like I said, again, first we're gonna draw the line of the main shaft, the line center line first. So to draw the center line, like I said, it is a dotted dashed line. I'm gonna draw a dotted dashed line real quick. No, actually I might just use a this thing because it's clear and it's like easier for me to draw with it. There we go. The lighting is a bit bad. I will find a new place to record in after this. We're gonna have our, there we go. This is gonna be our center line where our shaft runs through, and then we can copy this the sign here onto our shaft. So yeah, let's go ahead and just do that. All right, we're gonna have remember there's gonna be a shoulder around here, so I will put a shoulder up there. There's my shoulder. Let me just quickly put a tiny shoulder right here. Right, and then we're gonna have a bearing here, so let's make room for the bearing, and then let's leave some space. Let's put our bearing right here. Then we can leave some space. Let's say this much space. Now we can put our next bearing here. No, not like that. That makes sense. Then we're gonna copy the thing down here too. Right, and then we're gonna have a shoulder here again. Now, when drawing these, it is important to be calm, and I mean, if it is a pencil sketch, then you're not gonna have any problem making trouble. If you make, you're not gonna have any trouble making problems. Sorry, if you make a problem, then you're not gonna be in trouble because you can just erase it. But if you are drawing in pen, which I highly do not recommend, first draw your sketch in pencils first. If you are using a pen, then if you make a mistake, then you're kind of in trouble. So I'm gonna draw my bearings right now. There we go. Then let's so here I'll show you the important part of drawing the bearing. Right. And now let's draw the housing part. Yeah, let's draw the housing part and we'll work on the bearing. I think that is much better. So the housing is gonna have a shoulder here, 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 and here. Oh no, messed up. Like I said, if you mess up, you can just make your mistakes go away with an eraser. I like how this pencil has a built-in eraser that makes life a lot easier. By the way, if you're watching this alone, you can just skip ahead, you know, like recording the whole thing without cutting anything, because I want people who are following along to kind of follow along at their own pace. That's why I'm also going kind of calmly, slowly, so that they can catch up. But yeah, if you're in a rush, you can just skip ahead, you know, double tap, or I don't know, right arrow on your laptop. There we go, and then just complete the housing. There we go. So our drawing is complete. Look at how beautiful it is. So let's fill in the bearings. So to fill in the bearings, we get a look at the line of action of forces. So for this bearing, it's going this way. So we're gonna have more area up here and like less area down here for this side. Like I'll show you what I mean. So if we draw our bearing arrangement like that, we can draw it kind of like this. It's easier to show you what I mean than like, yeah. So if we shake this in, then it becomes apparent. So we have like there is more force here and like more force here and less force here, less force here. You know what I mean? Same on here too. We're gonna look at the shoulders and see the line of action. So I mean, because obviously we're drawing all bearings, we can also look at the principal sketch here and see that they are doing it like that, you know. So here and here, then here and here. There we go. Then same on this side. So great thing is that they're mirror of each other. This is a mirror of this and this is a mirror of this. So if you have drawn this, you can just kind of copy it down here by mirroring it, and then you can also kind of mirror this onto here, mirror this onto here, or mirror this onto here. You know how it works. There you go, and same thing down here too. And now for the housing, we are gonna do the shading but in the opposite direction. So the diagonal lines are gonna be in opposite direction, also like larger, like they're gonna be differently spaced, so that you can distinguish between bearings and the housing, not get confused. There you go. And that is it. This is our technical drawing in pencil, of course, of all arrangement bearings. So now let's draw it in pen. There we go. Now let's draw the shaft. I think I misaligned it by a bit, but that's fine. Just basically copying this, you know. Can't really make much mistakes here if you're using a pen. So let me just draw one by one. Let's draw the shaft first and get a general idea of what the shaft would look like. Should be good. I think I drew it a bit longer. Yeah, it's fine. Well, I guess this is like a bit different. There we go. This is our completed shaft. Now let's put our bearings in. Same on this side. Then let's top it off. So in the exam, it is wise to have these circle drawing things, like the one with the plastic ruler with holes in them, you know. It's like a plastic board, a cutout with holes, a lot of different sized holes, circles in them. Means also nice to draw in, like, it's also okay to draw with your hand, but it's a lot nicer and a lot neater, a lot tidier to draw with the cutout. And then this one is gonna be facing this way, so you can kind of imagine, yeah. This one is gonna be facing this way. Like that, yep. And then this one, like that. And then this one is gonna be facing this way. Basically just mirror the other one. Then let's shade those in. Same this too. Alright, there you go. Then let's draw in our housing. Um, then same on this side too. Oops, almost made a mistake. By the way, it is also nice to use pens that are not necessarily like gel pens, because gel pens will spread a lot. Like, look at this. I'm rubbing my hands on this. It's not spreading. Which is why it's nice to use like dry ink pen that are like fast drying. You know, the ones that don't make a blob. Yeah. So let's shake these. And there you have it. This is our O arrangement bearing. I forgot to shake this part. There you have it. Sorry. There you have it. This is our O arrangement bearing technical drawing completed. So we have our principal sketches drawn in pen and pencil, and then we have our final version drawn in both pencil and pen. So just to recap, remember, first when you're drawing a technical drawing, first draw the principal sketches first, use the horizontal line as your center line, and then draw the bearings according to the image I showed before. Use a pencil, and then after you're confident, use a pen to draw the exact same thing. And then before you draw the technical drawing, make a little sketch of what it might look like, what you want it to look like. Using that sketch, follow the sketch, and then you can draw your drawing in pencil first, and then copy that pencil drawing onto a pen drawing. Right. Then in that case, see you in the next video. I will be talking about, hopefully, X arrangement bearings in the next video. So yeah, this is the O arrangement bearing. We have contact points here, line of force, line of action of the force going this way, this way, this way, and this way. You can see here shoulder, shoulder, which means that the forces are in this direction. Shoulder, shoulder, forces are in this direction. So if you trace them, you get an O arrangement. That is our O arrangement bearing. See ya.